Today we're going to do the elimination method for solving systems of equations. Okay, so we've done graphing so far, finding out where our lines cross. We've done the substitution method where we take one equation, we plug it into the other equation, and now we're going to learn the elimination method. You might say, well, I already know two methods, why do I need another one? But if we look at this problem right here, and we start it with the substitution method, you would have to get x or y alone. And that would involve maybe adding 5y to both sides and dividing everything by 3. And you would just have to work fractions all the way through your problem. You notice both of these problems are in standard form. And so this is really set up for the elimination method. Here's how you do it. Your goal is to add the equations together. So we want to add the equations together. That's a little weird. We haven't done that before. To eliminate one of the variables. All right. So our goal is to eliminate, that's why it's called the elimination method, one of the variables. Now, how do we make that happen? Well, we got to line everything up and fix it. Show you how to fix it so something cancels. Well, to get something to cancel, like 4 plus 3, that gives us 7. But 5 and negative 5, that cancels. That gives us 0. That's what we're looking for. So this problem is ready to go. Everything is lined up, even the equal sign and the constant. And if we add them together, the y's would cancel because 5y plus negative 5y would be 0 y's. Okay, so if I add this together, this would be 7x plus 0y equals, don't forget to add this together, 14. You can see what happens here. 0 times y is 0. So we have 7x equals 14, divide by 7, and x equals 2. Don't you love it? And you have half of your solution. Remember, it's still an unordered pair that we're looking for. That is the x value. And just like the substitution method, we're going to take that 2. We're going to put it anywhere we want for x. So I don't know, if we take the top equation, it does not matter which one you choose. Right? So this would be 8 plus 5y equals 6. All right, subtract 8 on both sides. 5y equals negative 2, divided by 5, and y equals negative 2. All right, and that is the other half of your solution. Okay, so these two lines, if we graph them, they would cross at 2, negative 2/5. All right, so our goal is to make it look like this, where everything is lined up and something cancels, okay? But we might have to fix that, so let's look at this problem. All right, we got A's and B's here, it doesn't matter. We need to make sure that everything is lined up, even the equal sign and the constant, so we're good for that. But if we add these together, I'm not going to get a 0. Either A has to be eliminated or B. So this would give us a 3. That would be a 7. So the next trick is that you are allowed to multiply either one of your equations by anything that you need to make something cancel. You could divide too if you wanted to. But if we look at this, we know we have to have a positive and a negative for it to cancel. So if I just multiply everything in the top equation by 4, I would get a negative 4a right here. Okay, so I'm actually going to work across my paper. And that seems weird, but it keeps things lined up nice. This would be negative 4a plus 8b equals, 28. Now this is where people tend to forget. They forget to multiply that constant. All right, the bottom equation is not going to change. and we're ready to add them together. So here, the A's cancel. We get 13B equals 39. Divide by 13. And B equals 3. So not too shabby here. Some people like it better than substitution once they get to it. All right, so this is B. That means I can put it in any of my B values. So I'm going to take, all right, the top equation. I'm going to put the 3 in there for the B value. Minus 6 on both sides. Remember, that's a negative A. Whoops. Equals 1. Divided by negative 1, and A equals negative 1. So if I had to write this as an ordered pair, we would go alphabetical. So we'd have negative 1, comma, 3. All right? Let's do one more. This one says be careful. So you know that means we're gonna have a lot of work here. Okay, so be careful because they are not lined up. It kind of looks like an X and Y and 6, but look at your equal signs. Here, X and Y are split, and on the other one, they're on the same side. So we have to first put everything lined up. So you got to decide, either you split the bottom, or in the top, you put them on the same side. So I'm going to do that with the top. I'm going to subtract 2y on both sides. Right? So this is gone. And 3x minus 2y equals 6. And then on the bottom, you can stop this video anytime you need to just kind of look at what happened. We didn't change anything. Now we try to add them together to make something cancel. So this would be 8, and that would be 5. So nothing's going to work there. We got to decide what will make something cancel. Well, I can't multiply here to get a 5 or a 7. So I'm going to have to change both equations this time, right? So if you look at it, you say, I could make this both a 15, or I could make this both a 14, right? This one's already negative. So let's do the y's. Let's multiply the top equation by 7 and the bottom equation by 2 so that we get a 14 in the middle. Okay? So 21x minus 14y is 22. 10x plus 14y equals 92. Now, if we add them together, the 14s are gone. The y's are gone. So we have a 31x equals 124. All right, and if we divide that, we have 4. So x equals 4. Okay, goodness. All right, so that is half of our solution. Remember, you got to plug it back in. Now, we've got 1, 2, 3, 4, 5, 6 different equations that we can pick from. It doesn't matter which one you pick. I don't know. Let's pick this top one. Got smaller numbers, right? So 3 times 4 equals 2y plus 6. Minus 6 on both sides. Divide by 2. And y equals 3. Okay, so that's our first go around with the elimination method.